Let's take a look at LeetCode problem 39, combination sum. Given a set of candidates without duplicates, and a target number target, find all unique combinations in candidates where the candidate numbers sums to target. The same repeated number may be chosen from a candidate's unlimited amount of time. Okay. All numbers including the target will be positive integers, and the solution set must not contain duplicate combinations. And in the constraints, it mentions the candidate's length is between 1 and 30. So we have at most 30 candidate integers. And each integer will have value between 1 and 200. And each element of the candidate is unique, so we won't have duplicate integer in the input array. And target is between 1 to 500. Okay, so in the first example, the candidates is 2, 3, 6, and 7, and target is 7. So here are the two combinations we found that the elements can sum to 7. Yeah. So how to solve this problem? Let's take a look. Let's just use the first example to help us find the result. So the candidates array has 4 elements, 2, 3, 6, and 7. And our target is 7, right? And we are allowed to choose the same number, unlimited number of times, as long as we can eventually sum them to the target value. But we are not allowed to have duplicate combinations in our result. What does this mean? Let's say we have 2, 2, 3, this combination in our result. So later, we cannot have like 2, 3, 2, right? So even though the second combination also satisfy our requirement, all the elements can be summed to 7, the target, but we consider these two combinations as duplicates. So in other words, the order doesn't matter in the combinations, right? So how can we achieve this goal that won't have duplicate combination set in our results? I think what we can do is every time when we try to find a number, right, we have a pointer, let's say we point at I, we can only choose the number on its right side, including itself. For example, when we at position 0, we pick up 2, right? And we can choose from 2, 3, 6, 7, right? But if we move our pointer to 3, then we can only choose element from 3, 6, and 7, right? So we want to like choose any number that before the current position, so that can help us avoid duplicate combination set. Okay, now how can we find all the combination sets that can sum up to the target value? So what we can do is we just keep selecting an element at a time, And every time when we select a number, we add that number to our list. The list is going to be a temporary data collection. We can call it pass actually. So every time when we add a number to our pass list, we check whether the target has been reached. If yes, we add it to our result. Otherwise, we just keep exploring, keep adding new number into our pass, right? This, for example, so if initially the pass gonna be array is empty, and then we add a 2 to the pass. So now our target will be 5, right? And then we add another 2 because we can use the same number unlimited amount of time. So now our target becomes what? Becomes 3. Right. Now we keep adding 2. So now the target is 1. We try another 2. And now the target becomes -1. Okay, so at this point we can keep adding 2, right? But we don't have to do that. Actually, we should stop here. Why? Because all the numbers will be positive. So at this point, our current sum already exit our current. If we keep adding values to the current path list, the sum gonna be larger and larger. It will always exit our target. So anytime if our new target becomes negative, less than 0, we should stop here, right? When we stop here, what should we do next? We should try another number. So we should remove the last added number from our path list. We go to our up level, and then we just try to add another value. So we keep doing so until we tried all the possible candidates at this level, right? And now, like, we don't find any combination set that satisfy the requirement. What we do is, at this level, we remove the last added element, go back to its up level, select another element, which is 3. So our next one becomes 2, 2, 3. And our target now becomes 0. So when we found our target is 0, we know that combination satisfies the requirement. So we add it to our result. Right. So as you can see, every time we need to remove the last added element from our path list. So this is actually a backtracking technique. And how we avoid the duplicate combination sets. As I mentioned before, let's say our start candidate value is 3. So when we find the next candidate number, we should only consider the candidate number after it and include itself. So we start from 3. right? So we start from 3, 3. If we pick up a value before the current value, which is 2 in this case, so eventually we may have a duplicate. Right? They say instead of select 3 here, we select 2. Right? Eventually we may have such a combination which is 3, 2, and 2, right? It's possible. If that's the case, these two combination sets will be considered as duplicated set. Okay, I think the idea is clear now. And let's try to code it. So let's first define the result. It's a list of lists. So we first validate our input. So if candidate is null or is empty, we just simply return the result. Otherwise, we just do this DFA search. It's like an unary tree DFA search, right? Okay, we call it backtracking. What we need to provide in this method is the candidates array, our target, and our start position. Why we need a start position? As I mentioned, it will help us to avoid duplicate combination sets. If we are at a certain position, we only choose the number on its right side and also include itself, right? And then we need a path which will be a list. Okay. And we need to store all the combination sets to our result. When the backtracking is done, the unretrieved DFA is done, we just need to return the result. Right? If this part is not clear, we can code it in this way. Okay, so now how to implement the backtracking help method. So we need a candidate which is an integer array. We need the target. We need a start index. We also need a list type path variable, and also we need a list of list result. Right. If the target is less than 0, what we do, we just simply return. Right? If the target is less than 0, we know it's meaningfulness to keep adding new positive candidate number to the path, right? And second case is if the target equals to 0, we know we found that combination. We just need to add that combination, which is a list, to our result. So why we need to do to create a new list here instead of like directly add a pass here? Because the list is a reference type parameter. It's a class, right? So the value gonna be changed over the time when the program keep like executing, right? So we need to make a deep copy here to store the value. So later, this value, the value of the pass at this point won't be changed. So that's the reason. If not, what we do is we just keep trying every candidate number. So we need to start from our current values because we only pick up the value from the current position and it rightward, right? And I so first thing we need to do to add the current number to our pass. Then starting from here, we go to the next level of recursion, right? We call our backtracking again. So now if we go to the next level, the new target will be the original target minus the current candidate integer. And since we can select the same candidate number unlimited number of times, we just start from I, right? And we also need to pass our pass and our result. And next part is how we remove when we finish all the possible combination at certain level. When we go to its up level, we need to remove the last added element, right? So that's going to be pass dot remove at, we remove the last one. So this is going to be our implementation. Candidates okay. Start doesn't exist. Oh, originally we start from 0, right? We start from 0. We can pick the first candidate value. Okay, so let's submit it. Accepted. So what's the time complexity of this solution? So essentially, as we can see, it's an n-ary tree, right? At each level, we roughly have n nodes because we have n candidates number can choose, right? And the thing this is an n-ary tree, what's the depth of this tree? So our target is a fixed number. Every time we need to minus the smallest number from this target. So the worst case is the tree has a height of a target. right? Actually, it's gonna be smaller than the target. It will be target over the minimal value. So this number gonna be the height. And at each level, we will have n node, n candidates. So this gonna be our time complexity. So roughly it's all nt, right? So how about the space complexity? Yeah, similarly, space complexity, since we are doing DFS, and it's gonna be the height, right? Which is the call stack. So complexity for the space will be T over the minimal value, or roughly OT. Okay, that's the implementation for this problem.